Welcome back from lunch. Hope it was delicious and fulfilling and got yourselves ready to learn a lot more. I did notice something that I thought was hilarious at lunch, and I wonder if they're still in the room, but it looked like there was about 4 of you that were really tired and went outside for a little nap. I definitely took a couple pictures of that. I think some other people did as well, so I'll definitely be hashtagging that little guy on the Instagrammy, whatever, the technology. Anyway, thanks for getting back. We have 2 hours of training set up for you coming up now. One that's going to be here in the big room, and then we'll come back and divide you out into smaller breakout sessions that I think you should have just gotten an email last night about to confirm which of the breakout sessions you're in, but we'll cover that in about an hour. Right now, I would like to bring up Gabby, who will be chatting about APIs and cloud. As her fun fact, Gabby is an avid Lego hoarder with over 40,000 Legos, so building literally everything out of Legos. Welcome, Gabby.
Hello, good afternoon. Today the talk will be about machine learning APIs. I am not a machine learning specialist. I'm a developer advocate. In fact, I don't know machine learning. I know APIs. So I want to know here who have messed around with any API of any kind. Oh, awesome. I'm not going to make you do curl requests because I'm not that mean, but I'll be able to show you some of the cool things you can do with the Google API. As a developer advocate, part of my job is I am a software engineer to teach you software engineers or future software engineers how to use Google's technology and gather feedback from you when something breaks or doesn't work as it should. So what is machine learning? I have a colleague called Cassie. She's really good, and she's also an DA. And she defines that machine learning as a thing labeling stuff. It's made out for you to label things that you don't know how to define sometimes. So you come from imperative languages sometimes where you have all these if-elses defining what is going to be what. And on machine learning, it's different. It's a different program paradigm where there is no recipe specifically already done. You need to come up and train the model, and that improves over time. So it's learning by experience, by example and experience. And you don't have those specific rules because those rules can change. And because everything else, it's like being able to learn interactively in iterations. You learn a bit today and you learn a bit more, and that's how machine learning works. Machine learning also can answer questions that you don't have the answer yet. That's why you use AI so heavily here, and being able to answer questions like I saw the previously talk on the self-driving cars. You don't know how it's going to behave, but you need to predict, and that's how machine learning can help you. So we have all these products at Google, all of them using machine learning at some point, especially the keyboard. If you use an Android or even iOS, you can use the Google keyboard. It's really good. My favorite one is Google Photos, because I'm not really good on doing animations, so I sometimes am surprised by stuff like this. That's my puppy. Her name is Ada, and she's really cute. She's 10 months old, and she does have a Twitter and an Instagram. You can follow her. Yeah, notice, Ada Doglace. Okay? Okay. So I have a little exercise for you. I want you to help me. How would you identify the following images? On the left, I have an apple, and on the right, I have an orange. So how do you identify one for another? Color? shape. So color, usually it's the most easy one. But then the machine cannot get the flavor of it. It's a bit different. We're not there yet. So, okay, you use colors. One could say you could create a script that would count how many red pixels are in the apple and how many are in the orange, and say if there is X amount of red pixels, it's an apple, else it's an orange, and that solves that problem. But when you come to this scenario where you don't have color anymore, you need to think again how you're going to solve it. And yes. But then you're determining how it's going to behave, how the result's going to be. And you don't know how all the possibilities that's going to exist for an apple or an orange, okay? Not there yet again. Moving on. Okay, how do you differentiate this one? Both of this. It's easier, right? A dog has 2 eyes, a nose, and a muffin just looks nice and delicious, I think. So, is this a dog or a muffin? It's not that easy in the end, right? Okay. And how about this? My favorite one is the bottom, the second one in the bottom. It's really hard to find out what it is. So machine learning come up to answer you, to help you identify this kind of problems that you would not be expecting. And it's loosely based on how the human brain works, how your process of learning is. We learn by iterations. Every day you learn a bit more about something, so machine learning is about that. It's solving the problem without specifically knowing the questions for the solution, and it enables and empowers the system to improve over time. So that's all about what machine learning is. So we have 5 API based on artificial intelligence here at Google. We have Google Cloud Vision, Google Cloud Video Intelligence, Google Cloud Speech, Google Translation, and Google Natural Language. I'll be explaining all of 5 for you. So Google Cloud Vision. Google Cloud Vision allows you to analyze complex image and get metadata out of it. And with a simple REST request, you don't need to do much with it. You say what the image is, and you do the call, and you get an answer. So we have a lot of features for the Cloud Vision API. So these 6 are the most common ones. Label and web detection, they work as the following. I have an image, and it returns to me what is the categories what that image could be. Like, for instance, the apple could return fruit, apple, red, that kind of labeling. And web detection would search through the web and show up images that are similar, or pages that have that image on, or some variance of that. OCR, it's optical, I forgot. Character recognition, thank you. And helps you to read whatever printed image you have in front of you. And it can detect not only the text, but also the language in which it was the text written on. Logo detection. If you have a popular brand, if you don't have a popular brand, that won't work. But if you have a popular brand, you may be able to find an image logo there, a logo that's appearing. And that may be useful, for instance, if you are, in a conference and you want to hide, the brand of the computer. So you just, you can run machine learning to see if there is a logo there and replace that image for that logo for something else. Landmark detection. It can help us find landmarks that are popular and could be man-made, like, I don't know, the Statue of Liberty, or some kind of nature things like the Iguazu waterfalls or the Niagara waterfalls. I can find it for you. Crop hints, you know when you upload your image at somewhere and says like, hey, it needs to be the ratio of 1:1 and makes you the square and shows you where to crop your image, where your face is, and that's what the crop hints does. And today, it's really common for you, if you're building an application, to have user-generated content. And part of this is, let's go back to the image profile upload. You need sometimes to make sure that the image is not inappropriate, and that's what the API also helps you do. There's other stuff too, and if you have an object on a page, on an image, let's say you have a flower plant, and it can tell you where the flower plant is on the axis of that image. So I'm gonna go to optical recognition example that I have in here. This one, it's in a Google office in New York. I don't know if you had a tour in the new Google's office, but like everything has a theme. Like at the Google office there, we have this, on this floor specifically, I think it is everything that's architecture. So that's why the name of the meeting room is the World Building. Probably is a famous building that I don't know, but probably is famous. You can see there that the API return all the things that were written and split into paragraphs. Second one, it's web detection entities. As I said it before, I hope you get this reference because I don't want to feel old. Who knows what this is? Okay, a few hands. So for those who doesn't know, there is this famous movie from the 1980s, I think, and this is Kirby, the Beetlebug, Volkswagen Beetlebug, was quite famous at the time. And I ran this image to find out what I could find about it. And the response that I got when running the web entities are entity ID, which it is a general ID for a label. You could have different images returning the same entity ID because they may be similar in some characteristics. A score, and the description itself. I clipped the response because the response was really big, and I just put the three first ones. In this case, I found that's a car, that's a Volkswagen Beetle, and it's Volkswagen. Web detection. Remember that I told you you could find full pages with the image, images that are similar, and images that are the same. Why would you do that? Copyright infringement, it's one of them. Like if you have a picture, you put it on your blog, you took yourself, and someone else will go there and copy and put on their blog. If the page is indexed by Google, chances are we will be able to find your image on the full matching images response of the API. So I have a demo now for Google Cloud Vision. I'm putting my password, I'm sorry. So someone talked yesterday about Jupyter Notebooks. I don't know if you recall about it. I like subverting the use of stuff for the needs that I have. So instead of using terminal and running a script all the time or creating an application from scratch, I use the Jupyter Notebooks just to do my demos. It's the easiest way possible for me. So this first line here is just to help me print with Markdown. It's not necessary for the demo itself. The demo starts on the second part. Can you read it, or do I need to increase it? It's okay? Okay. So you see that first I import the Google Cloud Vision library, and you can pass a file name as a URI or URL, or the Google Cloud Storage URI, or even the image itself, upload the image itself for the API to be sent. Once you do that, you say the source of the image and instantiate the client to do that. I want you to help me and tell me, what is this? Okay, thank you. So we're going to use landmark detection, right? If this is a landmark, it's going to tell me it is a landmark. And you said that's the Eiffel Tower? It's not. It's the Paris Hotel and Casino in Las Vegas. Part of that, you can also see where it is located, but like I know that's in Vegas. So, and part of that, the response that you can get with the API is the label detection as the categories that are associated with the image. So for this image itself, it is labeled landmark, sky, tower, building, tourist, and so on, so on. And to show up the web detection to see where there is similar images, I'm gonna get it an image. I'm passing the image again, and I'm gonna get the visually similar images there are to this one, and I'm gonna choose one randomly to show up here for you. It's running. And you can see that's a different shot of the same image, same landmark. So this example, it's a Python. You probably know more Python than I do. My first language was PHP, then JavaScript and Ruby. I know it doesn't get better. It just gets worse. So I do have another example here to show you. This one in Ruby. That's the same thing. I'm importing the library, and I'm going to show you another image. What is this image? Come on, people. OK. You're really, really not trusting me, aren't you? OK. So I'm going to instantiate the object here. And once I do it, I'm going to find out which landmark it is. It's not the Golden Gate Bridge again. It's the 25th of April bridge in Portugal. It's really similar. So those are the descriptions that are related to this image. You can see here that San Francisco Auckland Bay Bridge up here. It's because when this image was indexed, Google gets the content that's on the same page and tries to find relevant information to add to the image. So that's how it works. And you can see here that's Lisbon and Portugal. I did the same thing here. I'm going to count how many similar images there are. In this case, there are 31 similar images, and I'm going to get a random one. It's the same picture, but it's in a different scale. So these are using the label detection and web detection. I have another image here that I want to show that uses face recognition. It's not face recognition as in trying to match a face to something else or to someone else, but as in trying to find the expressions on your face or what you're wearing and that kind of information. So this is a picture that I took. And you can see here that it's extremely likely, very likely that I'm experiencing joy, and I'm possibly using headwear, probably my glasses, they're saying, with a confidence level of 90%. The labels associated with this, each one of them has a confidence level, so you can filter which ones, like, I don't want labels with less than 70%, for instance, so you can ignore them. So vacation, yes, and it says brown hair. My hair is not brown, but like, that's OK. And web entities again, and because this is a private picture, it's not online. There is no matched images or partially matched images at all. And this is the part that I would like. It's really fun because it gets the dominant colors and shows up the crop hints that I told you about. So if I want to publish on Instagram, I probably want to have this one on aspect ratio of 1 and aspect ratio 1.2 if you want to publish, I don't know, on Facebook. Safe search is going to return that's not an adult. It's very unlikely. But I don't know why I say it's racy. And in the end, you have all the JSON response in here. So you can try yourself by accessing cloud.google.com/vision and upload your image, whatever image you have, and you can play around to see the responses you get. Just to finalize, to show up how crop hints work, I have this one, which is me, my husband, and my puppy. And see, even though my husband's face, it's hidden by the puppy, it was able to recognize there was a face in there. And that's the phase 1 level of confidence, and the phase 2 here. Because it's a bit hidden, the confidence level, it's lower. Now, when I go to properties here, the crop hint is not nice. I don't know what they want his hair. I don't know. So I'm going to go back to the slides now. So this is the code, mostly the code that I use to do the Cloud Vision API request. You see, the third line actually is not necessary. That's real-life coding, where you put stuff, play with it, and forget to remove it. So you don't need the third line. And if you want to see if that's not really good to see, I put this one on darker one too. It's in the end, it's about 17 lines, but there's comments, and you can easily do an API call yourself and get to play with it. That's my advice for you, play with it. You're gonna get so much different answers and responses that it's gonna find it fun. That's about it. And if you want to learn a bit more about how people use in production, you have Giphy. They use our Cloud Vision API to label the GIFs that they have in there. So if you want to learn more, just access the GIF engineering blog. Cloud Video Intelligence. The Google Cloud Video Intelligence, it's used to extract metadata from to extract metadata from the video and label, as we did with Cloud Vision, and also do, on the level of the video itself, you can do a labeling of the video as a whole, or shots of the video, parts of the video itself. You can also see annotations on these parts of videos, and what label appeared when. Let's say on my video I have my puppy, and then I have a car appearing. It's gonna tell me there was a car and which part of the video the car appeared. Shot change detection. You know when you have a video that's edited and just changes? So this is possible to find out what changed on the video, when it changed, and also get annotations on that. Similar to the Cloud Vision API, it also has explicit content detection. So you don't need to worry if something is inappropriate, so you just check there. And regionalization here has nothing to do with translation or localization because of some regulatory countries. If you're familiar with GDPR, for instance, that Europe made everybody implement in the whole world in the end. This regionalization makes you say, hey, I want my video to be processed in the Netherlands, for instance, or in the US, because some regulations, especially in the Netherlands, does not allow data to come outside of the country to be processed. So that's one of the features you have in that too. So as to recap, you're gonna understand your videos and entities shot, frame, or video level. I have another demo for you. This one has audio. So this is a video, and probably, I don't know what about it is, but you can see here there are labels that are associated with the video. And you can see here the pink or red, depending on how you're seeing this. It's when this appeared on the video. So let me see when this desk appeared.
Engagement on a math
So you
worksheet.
can see a desk there. A teacher.
NEE. That means hello everyone. My name is Olivia. My own name is
Sunset.
Iago.
So, and
This
once
week
you
we
did
are
the
at the
processing
Indian Community
of the video, you save, probably it's gonna save that to a database. And no matter which database you are using, you can search by it. So let me search by sun, for instance. Right? Ah, okay. No, and I have another one, baseball. So this video, it's about baseball, but you can see in here when baseball itself appears, you can think that's cheating because it's showing baseball as a word or a hospital. That's are the contexts that you can use the video API. And if you look at the JSON response, I cannot increase the size, I don't know why. It's gonna appear like the one from the Vision API where there's the label and it's gonna tell you which second everything appeared. I'm sorry, I cannot make it bigger. It's not working. And what the confidence level it is for the label or entity. I have another video here. It's from Next, a presentation that I did on called SQL. And you can see the video, I already processed the video here because it takes a while. I already processed the video here, and I got software, tutorial, and page. But when I said you shot level annotations, you see there are 87 shots that were taken. That's because it's so much back and forth between slides. So this gets as online advertising, a presentation, a business organization, and more through the end here, it says public speaking, speech. So it got that I was behind the podium, so probably I was giving a speech. And on the API, you can see start time, end time for every one of the annotations that you have in there. I'm gonna go back to the slides. This is an example from bird's eye view. It's when you're looking from up, down, and that's the response code that you get it on it. You have a start time offset and the end time and the level of confidence on where that was, how much confidence there is that this actually is a bird's eye view. Google Cloud Speech. So Google Cloud Speech offers using Google's own machine, powerful neural networks that we have to do speech-to-text transcription for over 100 languages. Actually, I think it's 120 now that I looked, but it's growing every day. And the most used features are this one. Speech-to-text transcription, you're gonna get what was said and when was said with the speech timestamps. And profanity filtering, same thing as explicit adult content, sometimes people swear. And batch streaming transcription, it's example call center. You're calling, you need to have a record of that call, so you get a real-time process. Or even here, as I'm speaking, someone could be streaming this and doing closed captioning as I speak. So this one is the only one that doesn't work with a REST API, you need to use a thing called gRPC to be able to do that. It's a bit more special. I also have a demo for that. So as I said to you, it does the speech to text. So this is the whole text that was on the video that was able to find it. And it tells you when on the video was found.
Pixels in it. You can visit this link to play with it yourself. As you can see, JavaScript frameworks, you can build very rich websites.
So on.
I'm going to use my 100 megapixel one. You can download it at
You
this
can
link.
also search by something. I'm going to search by Firebase.
Firebase hosting provides fast and secure hosting for your Firebase command line interface, or CLI.
So
And in order
that's an example of how the speech works. I'm going to show you the architecture of how that works. Can we go back to the slides, please? So first, I extract the audio from a video. Then I send the audio for the Google Cloud Speech for transcripted timestamps. And we support, if I recall correctly, over 13 audio formats. So could be MP3, could be FLAC, depends on what you have. And then we create a UI to visualize the search videos. So this is the demo architecture. You saw a bit of this yesterday. I have my video content. It's stored on Google Cloud Storage. After that, I have two processes running. I have a cloud function that's going to generate a thumbnail to show up on the video, as I show you there, as you saw in the application, and store that thumbnail on the Google Cloud Storage. And the second one is going to get a Google Cloud function to extract the audio from the video, and then save that audio on Google Cloud Storage. Then, with Google Cloud Functions, be able to transcribe, get the transcription from that video, that audio, to your application. And in the end, we have a front end built on App Engine, just to show to you. Google Cloud Translation. It mainly, I use it a lot, and mainly has two sets of features, but it's more powerful when you integrate with different APIs. You can translate text over 100 languages and over 1,000 pairs, like English to Japanese, English to Spanish, and so you can do over 1,000 pairs to combinations to be doing the translation. And to detect the language of something, you saw something written and you don't know which language it is, Google Cloud Translation helps you to find out what was being said in which language. So as I said before, you can translate the text into over 100 languages. And this image you saw before, it was totally a coincidence. I did not steal from Greg. But that's a real-life example from Google Cloud, the Translate app, where it's the exit sign being translated into different languages on real time. That's probably combining the Google Cloud Vision API with the Google Cloud Translate API. I have another demo. This one is in Python. And this is a bit shorter. I'm importing the Google Cloud Translate library, instantiating the client. I'm going to do the most common thing ever, which is hello world. But my target language is going to be Japanese. Once I say that, I use the client to translate the text into my target language. So in the end, we get hello world and this thing here, which I cannot read. But I'm Brazilian, I can speak Portuguese, and I can find out that's hello world. It's Olá Mundo. You can do it for over different 100 languages, and you could do, let me translate back from Japanese. I'm gonna copy here. it should work. Let's see. To English. It does work. Thank you. Then, because I'm mean to you, I'm going to do the same example in Ruby, but a bit differently. It's importing the library here, and I have this text here. How long does it take for the plumber to fix the sink? I don't know, just was something. My house wasn't working, the sink, so I had to do something. And once I instantiate the translation object, I'm going to translate it to Spanish, for instance, which I can't speak, I'm sorry. So if it is wrong, tell me, but I think it is correct. So the same way that you did on Python, you can do in Ruby, you can do in PHP, Java, Node.js. We have tons of client libraries. That's why I'm always showing you examples in both languages. So you don't get too attached to one thing. You can do everything in all the languages that we have client libraries for. I'm going to go back to the slides. So this is the code. And this is another real-life example of how code comments go stale. Can someone find the error there? Yeah. When I did it was in Russian first. And now I changed to Japanese, so it stayed that way. So code comments go stale. This is the same code, but just with different coloring if you have difficulties seeing it. And finally, Google Cloud Natural Language. You can use Google Natural Language API to get the meaning of sentences or phrases that you don't know how it works. You can get words can be called tokens, and you can find a dependency tree, like which word depends on what, and that kind of information. We have 4 main uses. There's more uses, case uses for that. You can extract entities, and entities here are stuff like localization, or if there is it's a person, or it is a product. So it's going to classify it for you like that. Detect sentiment. So if I write something, it can return to me if that sentiment is positive, negative, or neutral. And that's in a lot of languages. I don't know the exact number of languages, but we are having this feature on different kinds of content and languages. And then I remember studying Portuguese when I was a kid, and I had like this grammar book, and it was like this thick. And I wish I had Google Cloud at the time, because it does syntactic analysis. So you can get like, oh, this is a noun, this is a verb. You can see all that kind of stuff. And in the end, you can classify the content. Let's say you have a text and you want to categorize that. You have to have at least 20 words to be classified, and it for now only works in English. So I have an example here. I went to the restaurant and ordered sushi. The food was really good. This is using entities to get the result of what it is important. So it says a restaurant is a localization, and sushi, consumer good, and food is categorized as other. Another example is the same phrase to analyze the sentiment. You can analyze the sentiment of the whole document. In this case, I got a positive sentiment of 0.3, and magnitude is how much I am feeling that. It could be from 0 to infinity, and the score can be from -1 to 1 with that scale behind me. So even though I went to the restaurant and ordered sushi, it's neutral, I got a negative score, but it's still neutral. And the magnitude is just like, I just went there and got sushi. So makes sense. And the food was really good, positive, and a bigger and higher sentiment on that. Syntax analysis. Back to the book. That's what I like about this. Of course, you don't get the image on the API response, but the API response gives you that kind of information. It tells you the lemma. The lemma is like in order. Order is the lemma for it. It means the root word for that I don't know the word now, but for that derivative of that word. And you can find out if there is a verb and if it's singular and which person it is. So you can find out, for instance, went. It's everybody depends on went because I only got to the restaurant because I went there. So it's able to tell you the dependency on that. And content classification here. This is a newspaper article or magazine article, and it doesn't mention the word baseball anywhere in there. But on my response API, I got the category there. It's sports team, sports baseball, with a confidence level of 99%. So that's because it's in English. I have a demo now, and this one, it's gonna integrate 3 APIs. First one that I want to do, I'm on Twitter, and I'm looking on the GCP Innovators hashtag. So if you want to tweet something here, oh, nice. So there's something here. So let's analyze the sentiment of that tweet. I created a Google Cloud function that takes a tweet, gets the tweet content, and says to me which sentiment that have. So let's see. You copy the ID. And for now, I don't have any message. And I'm going to add a message here. And let's hope it works. Come on. It's warming up. It does. So who said it? Sentiment neutral, score 0. Don't know why. Let's see another one. Zero doesn't mean it's just neutral. It doesn't mean bad. This one was faster. So 30%, 0.3 as positive, and the magnitude was 0.8. If you want to play with that and see which sentiment you have, please don't do a bot because I'm using my API keys. So if you do it, it's going to rate limit. And this is a URL shortener that I have to that Google Cloud function. And if you want to do the example, just put message equals the ID of the tweet that you have. And the code for that is this one. It has a lot of lines just because of indentation. But I'm getting the tweet, and I'm returning with the text and the username. And once I get the tweet, I get the content of it, and I get the document sentiment. And then I return all of those 4 items on my Google Cloud Functions. This Google Cloud Function is in Python. It's beta. It could have done in Node.js, but like I decided to learn Python to show you. Please don't judge me. But this one, you can play with it. And you can see here, someone showed you Stackdriver yesterday. And this is all the requests that took here. For instance, this one got it wrong. status ID must be int. Someone tried to put a string there, probably. Another demo that I have here, this one uses the 3 APIs that I told you, the vision, the translate, and the language API. And I have an article here. This is the article that I have. I'm not going to tell you what it is about. But if you don't know Portuguese, that's the point. I want to know what this article is about. So I'm going to instantiate the Vision API. And once I do that, I'm going to get the text of that image that's in there. With all of the API calls that I showed you before, this is the result. It says which language it is, and it gets the transcription of the text. See the hyphenization continues because it was hyphenated on the image, so it kept the hyphenization and the break lines. And I thought the first time I did this that this is not going to work because it's like it's breaking the words, how it's going to know. And actually, that doesn't matter. So when you do the translation here, it's not perfect, but like the hyphenization did not break my translation. It still is there. It's in English right now. And then, because I want to know what it is about, the content classification of that. So it's about jobs, education, and admission tests. That's about a test that you do to enter the university in Brazil, and the confidence is of 50%. I have the same one because I told you, do not tie yourselves to one language only, and this is a different image. This is when I went to the Netherlands, and I got this flyer here. I kind of got the gist of what it's about, but like, let me translate it and see how it goes. So again, the break lines are in here, and get the translation. And it's about Wi-Fi, probably, and determine the classification. Internet, telecom, service providers, or computers, electronics, and networking. So you can have more than one classification to the same subject. And back to the slides. If you want to know more about the APIs, I recommend you to access those links. It has documentations you can do interactively. All of this that I did on the Jupyter Notebook here, you can do it on the web, there is a client where you can do it, so you don't need to have that implemented already. And that's it. Thank you. Does someone have questions? Wait a moment for the mic.
So what's the speed like for like larger scale? So let's say if you're trying to do video intelligence for a video that's like 45 minutes, how does it scale in terms of how long it takes to process everything? So
it probably uses the TPUs, which it is Google's own technology for machine learning processing. That video that I showed you with the annotations, it had 38 minutes, and it took, like, I think 3 minutes to analyze it. So it depends a lot on the load and how complex the video is. It's not just how long the video is, but like all the information there is on the video. So I cannot tell you like, oh, it's going to take 5 minutes for sure. There is size limits, which it is on those links. You can see it. I don't know by head, but I think it's 1 gig, some 5 gigabytes or something per video, or that kind of stuff. Any other questions? I'm that bad? Okay.
How much of this technology is used in YouTube? Like, does all the video get uploaded, get like filtered with this sort of technology? It seems like it would take a super long time.
So YouTube actually doesn't use specifically these APIs. I wanted to talk about AutoML, but I did not have the time for it. But they probably are running their custom model to do that, and they can't probably scale that faster than. That's why sometimes when you upload a video, it's not available already because it's processing, and And now with copyright infringements, like for audio stuff, they can find if there's audio from songs that are copyrighted. So they do use something similar to this, but it's not this. This is made for anyone to use, and you can fine-tune it for the Vision API with AutoML and Google Cloud Translate and the natural language API. You can train your own model without knowing anything about machine learning. You just put examples there, and you'll be able to do so. Any other questions? There.
How does the cloud speech recognition API deal with people who have like broken English or like accents? Like, is it recognizable or?
So I can speak for my own experience because I have a thick accent. Sometimes it doesn't work that well. I have some videos, even with normal English. I had an example there that I did not show, and I don't remember which one it is. The closed captioning was not perfect because that's not a perfect model. It's always being fine-tuned by Google, but it can't guarantee that's going to be 100% correct, you know. But accents, it does find between languages and variants of languages. So for instance, I speak Brazilian Portuguese, and it gets my accent right, but it gets also right the accent for someone from Portugal, which the accent's quite different.
Oh, right over here. I think we have time for one more question.
Okay.
So do you know, first off, how many frames are skipped / how many frames are like actually analyzed by the Cloud Vision API? And then secondly, can you modify that and specify like, you know, maybe I want to analyze every other frame of a video just to speed up the process?
As far as I know, you cannot specify that. I don't know how many frames per second they are analyzed. Probably I would have to dig in the documentation. Thank you for the question. I can go back to you later on that. But you cannot say, you could clip the video before or doing small chunks using a cloud function, splitting the video. But as I told you before, we use TPUs to process that, so it may not matter that much. Depends a lot of what the video has, not how long the video is or how many frames it have. That's it. Thank you.
How was it? Good? Nice. All right, hey everyone. Looks like we have a couple minutes, so we wanted to, again, do a little activity. First, Eddie, prize for you. Would you like a prize for winning yesterday? Does everyone know why he's getting a prize? Okay, you've bragged about this enough? No? What was it? It's Tom's thing, right? Yeah. Okay, cool. What was the game? Trivia correctly, perfect. That's a good add-on into what we will do, which is more trivia. But I have a grab bag for you of prizes. So if you want to come up and pick out one of these things, and you can like look at what they are and sort of choose amongst them as your thing. That's my favorite, but you can always, yeah, it's a fluffy Android. Yeah, it's awesome. It's the best. I have like 7 of those at my house. Nah. Look, he's so greedy. Can I have all of it, he says? Why not? All right. No, that's the same. Yeah, okay, there you go. All right, tight. Well, congratulations. Hey, good job on winning. But I wanted to offer a way for other people to win something as well. So I'd like to ask this. Who feels that they are like an Android fanboy or fangirl? That guy's hand went up immediately. And your hand went up just a second. So if you want to come up, and if you want to come up in the back, yeah, come on down. No, this one right here in the white shirt. Yeah. Oh, you're both wearing Vaco shirts. That's hilarious. Perfect. Come on up. Come on up. And now, oh, here's my mic. Okay, cool. Of course, this is a nice competition between you two. So what we do, we're going to put you right here, and you're going to come up over here. Do a quick intro, name and school.
Hi, I'm Colin. I'm from Northern Virginia Community College. Hey, I'm Alma Madu from Morgan State University.
All right. And as Android fan folks, here's the competition. We'll go one by one, all right? So don't throw them all out at once. And the question is, how many Android operating systems can you name? But it's not all in a row. It's not all in a row. It's you start with one of them, then you say one, then you say one, then you say, so it's just one at a time. Oh, look at this. Now everyone's like, haha, glad I didn't volunteer. So, Android operating systems. Who wants to start? Oh, Colin's starting. All right, Colin. And I'm going to mark them down if you get them.
All right, Froyo.
Froyo is one of them. You have like choice of 12 of them. No? Can you get one more?
Oreo.
Okay, Oreo. All right, I'm gonna give this prize to Colin. Then I'm sorry. This is clearly a bigger fanboy on the Android. Who wants to compete against Colin? Oh wow, hand went up so fast. Come on up. Yeah. All right. All right. So you've nailed 2. Those are now out of the running. All right, challenger. Name and school.
I'm Emily, and I go to USC.
All right, challenger. You're
Jelly
up
bean.
first.
Jelly
bean, she says. Okay. Where is that on here? There it is.
Gingerbread.
Gingerbread is another.
I think marshmallow was one.
Marshmallow is one.
Did she say jelly bean?
That was her first. She did say jelly bean.
Honeycomb.
Honeycomb is one.
I think it was licorice one of them.
Licorice is not one of them.
No. I think I know this one. Is it lollipop?
Lollipop is one. All right. What else you got?
Key lime pie, one of them?
No, key lime pie is not one.
Kit Kat.
Kit Kat. Kit Kat is correct. Woo.
What do we do?
Woo.
A, B, C, D, F, G, H. Oh, I'm trying to think of the alphabet. L, nougat?
Nougat is, yeah, that is correct.
Pie.
Pie is the newest. Congrats, yeah. That just came out. Ooh, there are 4 left. Da-na-na.
Eclair?
Eclair, yeah, got the E. Woo-hoo-hoo.
Man, my first phone was Honeycomb. I don't know any other ones.
Oh, we got 3 left.
Ice cream sandwich.
Ice cream sandwich, yeah. 2 left. This is going way back in time here. 2 left, going way back in time.
My first version was jelly bean, so I'm
Oh,
trying to go
no,
back.
we got to go way further back than that one.
Chocolate?
You got the right letter, but the wrong,
Yeah, it's not chocolate.
the wrong dessert.
Too obvious. Caramel? No.
Not that either. Do you think you might have it? I can't remember any. The C or D?
Just candy.
Just candy, no. C or D, anyone? Yeah, you know it? Cupcake and D? Donut, right, so that's all of them. Hey, you guys, you know what? Good job up here, you two. I kind of feel like for the Android challenge, we should just toss out the Androids. I mean, this is an amazing job. Congrats. Thank you. Cool. I thought that was fun. I don't know. We sometimes do that on campus. I'll have people who think they're like Google fan folk come up and try to compete on how many products we have at Google. Those are some intense competitions because there's like 30 different products, and sometimes I forget even what they've already said to one another, and then just goes deep into like rabbit holes of product. Anyway, cool. So that takes us to time right now, which is great. We are going into a transition right now. If we can get the slide up with the different rooms on it. So we have 3 different rooms that you are heading to. You got one room that's right here, one room that's going to be right next door, and one room that is upstairs. So you should know which room you're going to. You just got an email about it last night. If you did not sign up on the form, then you are in this room, so that's easy, so you don't have to make a move on that. There are some brand ambassadors outside in shirts as well to direct to the 2 different rooms, and we will see you back here in about an hour. So go ahead out to those rooms. You got a little break as you head over there.